Hi guys, so this is Sezulu. We are back again with momentum. So today we're covering change in momentum. So change in momentum will be represented by delta P, right? When you see delta or a triangle, it means change. Now with change in momentum, we have actually the final momentum and the initial momentum, right? So the object has final velocity and the initial velocity. So it is going to be the final momentum minus the initial momentum. We know that momentum is mv, right? How we calculate momentum. So now we have the final momentum minusing the initial momentum. It's going to give us our change in momentum. Remember, direction is very important. Momentum is a vector, so don't forget that. So let's take a look at an example. So we have this ball, right? It's 2 kg in mass and is traveling to the right with the velocity of, let's say, 2 meters per second. Our ball will hit the wall, right? And return or bounce. It bounces back. Remember, mass is not lost, so our ball is still 2 kg, but its velocity changes. We need two velocities, remember, for us to calculate change in momentum. So let's say now it's 0.9 meters per second to the left, right? Remember, velocity is a vector. It has magnitude and direction. So now we have everything we need, right? We have masses, we have velocities. All we have to do is choose a direction. You need to choose the direction that is positive. So we choose to the right as positive. We choose to the right as positive, which means to the left is going to be negative, right? Don't forget that. You will see why it's important to choose direction. Because momentum is also a vector. So we need to have direction for our momentum. It's either to the right or left. We will see when we start to do the values or plug the values in our equation. So let's do the calculation now. So we chose to the right as positive. Don't forget, to the left is negative. Now, the final velocity here is 0.9 because it's when it bounces back. And it's going where? To the left. So it's negative 0.9. Don't forget, the negative comes because it's going to the left. To the right, we said is positive, right? So, which means that velocity, the 2 there, it must be positive. It's going to the right initially. So we have positive 2 there as velocity. Now, take out your calculator and do the calculation. Let us see how much is going to be our momentum and in which direction, or our change in momentum and in which direction is it. Right, so according to my calculator, it's negative 5.8 kilogram meters per second. So the negative there, what does it mean? Remember, we chose to the right as positive. That means to the left as negative. So it means that our change in momentum is actually to the left. Its direction is to the left. Change in momentum, it's a vector, therefore to the left. So you write it as 5.8 kilogram per meters or meters per second, where to the left. And that's it, guys. That's it. You choose your direction, you plug in your values, you get your answer. It must have direction. So thank you guys for watching. This is TS Tutoring. Remember, the full video will also be on YouTube. Subscribe and watch. Thank you very much.